Okay, this is the Unit 5 review, question 6 through 10. Initially I was going to do this in one video, but since that first video was a little over 16 minutes, I thought I'd just break it up into 4. So question number 6. A car's initial purchase of $30,000 is losing value at a rate of 3%. Which function could model that? So this is just basically, they all start with your initial amount, 30,000. And they're all going to follow the formula A equals A times B to the T power. And that base is going to be either 1 plus R or 1 minus R. And since it's losing, it's going to be 1 minus R. That's going to be decay. So we want to subtract that 3% from 1. Now 3% as a decimal is 0.03. You can divide that by 100 or just move the decimal over, but 3 divided by 100 is 0.03. So there's a 0 between the point and the 3. So we want to do 1 minus 0.03, and that'll give you 0.97. So that's going to be your base. So it's going to be the one with 0.97 in it. All right, question number 7. What is the logarithmic form of the exponential equation r to the y power equals g? Well, let's remind the formula for that. So exponential versus logarithmic form, the formula that I had it written was b to the y power equals x. So your base is the base in the log. So you write log, and then you put that whatever number or letter is being raised to a power, that's going to be that down there. In the log, we put what's on the equal sign. So, and then we set it equal to the exponent. So we bring the exponent to the other side of the equation. So in this case here, since it's y is in the exponent again, we want the y to be brought over. Now the base of that log will be whatever's being raised. So that r is going to be down here, which means the g would be what's in the actual parentheses of the log. So we go r to the y power equals g. We go out to the other side and come back. So log base r of g equals y would be your answer. Log base r of g equals y. Important that you separate the r and the y. So you don't want them together. And these all have them separate, but this, however, the way that it's written officially, the r has to be in the base. All right, question 8 is similar, it's just the other way. So what is the exponential form of log base e of g equals n? So in this case, we want to rewrite it as an exponent. So if you look at this formula again, it was always this as your base of your, would be the base of your exponent. So in this case, the base of your exponent is e. The power we raise it to is what's after the equal sign. So we go out to the other side, that's your power. And then we set it equal to what's actually in the log. So the g is the value inside the log, not the base, but the value in it. So it's e to the n equals g. E to the n equals g. Question number 9, which is the equivalent change of base form of log base 6 of 3? Change of base formula. Well, there's 2 ways to evaluate a log. One is to use the base that's given, and the other is to use the change of base formula. Let's take a look for a minute. If we go to Desmos, you could type in log, and if you do if you hold down the shift button, which I'm doing now, and I press the dash, I can put the 6 down in the subscript and press the right arrow and put the 3. And that gives me approximately 0.6131. Another way to do that is to do 2 logs. So you'd make a fraction, and on the numerator, you'd put log of the number that's in the value. So not the base, but the number that's written in a larger font. So that'd be log of 3, and your base would be log of 6. Notice those give you the same number. And really, again, what that means is 6 raised to that power is equal to 3. So that all that is giving you the exponent that you raise 6 to get you 3. But notice that these are the same. So in this situation, it would be log of 3 divided by log of 6, not the other way around. Because if it was the other way around, it'd give you a different number. And that's obviously not the same as that. So we don't want that one. We want this one here, log of 3 over log of 6. Question number 10, evaluate log base 5 of 100. That can be done using a calculator. You can do it using the change of base formula if you'd like. So log of, I'll write it down anyway so you can see it on paper. So for this one here, if I want to evaluate log base 5 of 100, I can do log of 100 divided by log of 5. Remember the default base for a log if you don't type it in is 10. So most calculators have a log, but it's base 10, and that would be the log that you would type in. So log of 100 divided by log of 5, or you can do, you can do log, you can do shift and hit the dash button to get the 5, and then do the right arrow and put the 100 in there. Let's see what we get. So log of 100 divided by log of 5 is 2.86, or log shift underscore 5 of 100, 2.86. And it says round to the nearest hundredth. Nearest hundredth is 2 decimal places, so 2.86 is perfectly acceptable. All right, so that'll conclude this video, then I'll do 11 through 15 on a separate video.